I'm going to create a two-way table of these two categorical variables, driver type versus origin of car. The setup is that the car parking lot is filled with three major types of cars: American made, European made, Asian made. There are two types of drivers: the staff and the student driver. So the staff owns 105 American cars, or the parking lot is populated with 12 staff owned European cars and 47 Asian cars owned by staff members. The students own 107 American cars, 33 European made cars, and 55 Asian made cars. So the question is there an association between driver type and origin of car? And I'm going to choose to think of this in rows. So the reason is the independent variable is the driver type. They choose which type of car to purchase. If they decide to buy a European car, that doesn't necessarily make them a professor. So that's why the driver type is an independent variable and the origin is dependent. So the independent variable dictates which direction I'm going. I'm going rows. Unfortunately, on the TI calculator, you cannot calculate in the row direction. So what I'm going to do in my head is invert the table. So the first column is going to be make. So the make of the car. No, I'm sorry. Yes, make of the car. So it will be American, Euro, Asian. The second column will be the driver types. This next two columns will be the driver types. So this one will be staff and student. Now, as you're creating this, you don't have a QWERTY keyboard like I do on the computer, so I would possibly go SFF for staff maybe, or SF for staff, and STU for student. Keep it simple and short. Now I have to look at the table tilted so that I am not, I'm going to put in the staff green numbers in. So that's 105, 12, and 47. And then the total would be 164. Forgot to put in the total categorical variable. Okay. And now the student, again, I'm tilting my head and I'm putting the yellow column in. 107, 33, 55, 95. The last column is going to be total. And unfortunately, I had a previous variable in there. So, something to be aware of. I'm going to click on the previous sheet that I have. And I had a previous problem with the variable of total. So I'm going to delete this from this previous screen. So note to self, every time you do a two-way table, create a new document. Don't create a new spreadsheet. You're going to cause problems. The variables you create in the first spreadsheet carry over to the other one. Just note to self there. This would be the white column at the bottom. So the total number of American cars is 212. Total number of European cars is 45. Total number of Asian cars is 102. Total number of cars total in the parking lot is 359. Yeah. Let's see. Did I check? Let me check my numbers. 212. Thank you very much for correcting me. 212. Okay. So now that I have my two-way table entered into the calculator, I'm going to go one column over, not two, one column over so that I can see column B and column E at the same time. And in column E, I'm going to call this is the staff percentage. So I'm going to type in P for percentage and SF for the staff. And the equation that I'm going to type in is going to literally be that variable name, which is SF. So I'm going to put SF divided by the total, which is 164. And then I go one column over, and this one's going to be P stew, and oh well, P stew. Hold on, it's saying that I already have a stew already. P stew, and I'm gonna put in literally the name of the column, which is STU divided by the total 195. Okay, then I go one column over. This is gonna be my total, so this is gonna be P tot percentage total. This is a well again. I already had this variable, right? I already had this variable from the previous spreadsheet. Cannot emphasize enough, create a new document before you start a new two-way table. That way you have a clean set of variables. P, tot, and it still retains the content of the variable. Just disregard those numbers there. And let me see, it's going to be equal to the total divided by 359, and it's going to say yes, I want to replace those numbers, and it's replacing the values from the previous spreadsheet, and now I have my two-way table. So if I look at this, I can just create a segmented bar graph with 3 segments each. So I'll have essentially I'm comparing this column with this column and comparing it to this column. Note, on the P total column, that is called your expected values. So I expect 59% of the cars to be American. I expect 12% of the cars to be European. I expect 28.4% of the cars to be Asian made. If I look at my distribution, I expect 28.4%, and I get that the students have 28 and staff has 28, so that's reasonable. Okay. Here I expect 12.5% of the cars to be European made, and yet I get 7% and almost 17%. So I don't get what I expect. So if I don't get what I expect, then there seems to be an association. Student drivers tend to drive more European cars, right? I expect to get 59% American-made cars, and I get 55 and 64. That's almost a difference of 10%. So what I expect and what I get are two different things. There does seem to be an association. My conclusion would be that 64% of staff drive American-made cars, while 54% of students drive American-made cars. Another comparison I could make is 7.3% of staff drive European cars, while 16.9% of students drive European cars. There seems to be an association between the type of driver and the origin of car. These two categorical variables are dependent.